Alright, let's talk about introduction to foundations and spread putting. The subject that we are talking about is building construction and material. First question in front of us is saying that a building foundation should be such that the settlement, and the options are, should not take place at all. Is it even possible that settlement will not be there? Settlement will not at all be there? No. When you are constructing a structure, when you are going for construction of a building, then after the construction the settlement are going to be there. The settlements will definitely be there, but the thing is, the settlement should not be uneven. There should not be any unequal settlement, non-uniform settlement. The settlement should be uniform or even, and they should be, the settlement should be in or within prescribed limit. This is the only thing we can do about settlement, that to keep it within the limit and to control it, that such that it doesn't go in uncontrolled or uneven or unequal manner. Okay, therefore first option is meaningless here, that the settlement should not take place at all. No such kind of foundation is there, or it doesn't practically exist yet, that no settlement will take place is possible. Okay, then settlement should be uneven. Do you want the settlement below your structure to be uneven? No, the settlement should be equal, the settlement should be uniform, the settlement should be even. Therefore option B gets ruled out here. Then the settlement should be even and within limit. Yes, that's the thing we are talking about, that a building foundation should be such that the settlement should be even and it should be within limits. This is the only correct thing that is appearing in the option. Therefore the most correct option here is, no, not even the most correct, the perfect option here is option C. Okay, none of the above gets ruled out here because we have found the correct answer here. All right, let's go to question number next. Okay, reason or reasons behind unequal or differential settlement is are. Okay, when they are saying reason or reasons and they are having the is are thing over there, it means that maybe number of options are correct here, and since we are looking at option D, which is all of the above, let's try to settle down at least with two correct options so that we can directly tick all of the above. We don't even have to look at the third option, but let's see all the three options here. Okay, slow consolidation of saturated clays. Yes, the consolidation process over the period of year or the period of months or over the period of years is going to cause some kind of unequal settlement, differential settlement, because the rate of consolidation, the manner, the fashion of consolidation may not be same at the all points. Okay, at every corner of the foundation it is not going to be the same. That's why it may be a reason for the unequal or differential settlement. Therefore option A is right here. Then shrinkable and expansive soil. The best example you can talk about regarding shrinkage and expansion when added with or when removed with, when kept absent with moisture content, is black cotton soil. Add moisture to black cotton soil and it is going to expand, it is going to swell, and when you are going to remove the moisture from black cotton soil, it is going to shrink. Therefore this shrinking and expansion, shrinking and swelling cycle are going to put a tremendous amount of stress on the foundation into which the soil is contact with. That's why the shrinkable and expansive soil are or may be the reason behind unequal or differential settlement. Therefore option B is right here. Uplift pressure. Yes, the upthrust that the foundation, that the structure is going to experience may not be uniform in all direction or over the overall area of the foundation. Okay, that's why uplift pressure, the intensity of uplift pressure, the magnitude of uplift pressure may not be the same at all the corners of the foundation or all the points of the structure upon which it is acting. Therefore uplift pressure may also be the reason for unequal or differential settlement of the structure. That's why all of the above is the best scene we can go with. Okay, all the three reasons are the probabilities behind unequal or differential settlement of the structure. Okay, let's go to question number next. Okay, foundation reduces the load intensity of superstructure by. Okay, the thing, the function that the foundation is doing is decreasing the load intensity. Let's first of all see what load intensity is, or simply what intensity is. Intensity is denoted by I, which is given by the fraction load divided by area. Now the thing is, whenever you are constructing a structure, the load for that specific size, the magnitude or the expanse of the structure is going to be the same, constant. Means you cannot directly reduce the load, you cannot just take off some load in order to decrease the value of intensity. But the thing you can do here is you can increase the area. Okay, for example, this is the structure. Okay, and if you keep directly on the soil, then intensity, load of the structure is going to be the same and the area here is less. But what if you increase the area of the structure, then keep it on the ground? What is going to happen? Area, this denominator has increased, that's why it will cause a reduction, a considerable reduction in the intensity. Okay, this is how foundation is reducing the load intensity of superstructure. Let's find out if we find the same thing in the options. Okay, the first option is saying by having a firm contact with the soil below. Yes, this is a fact, this point is correct, that a foundation maintains or it keeps a firm contact with the soil below. But the thing is, having a firm contact and reducing the load intensity are not at all related to each other. These two things are correct, these two things are true in their own aspect, but having a firm contact and reduction of load intensity are not having any similitude in their functionality, or they don't have any direct relation in between. Okay, although a foundation has a firm contact, but it doesn't at all help in reducing the load intensity. All right, then distributing the total load to large area. Yes, we just talked about this thing, I is equal to load upon area. Total load is going to be the same. Now if you increase the area, then the intensity is going to reduce. That's why option B seems to be right here. Then acting as a cushion for superstructure. See, when we are talking about a structure, then it is having this two part, superstructure and substructure, or superstructure and foundation. Now these two are integral part of a structure. A specific thing in between these two, that is the substructure cannot just behave as a cushion. It is not a cushion. Okay, it is the integral part of the structure which is carrying the load of superstructure and effectively transmitting it to the soil upon which the structure is constructed. Therefore, when we are saying that it is acting as a cushion, this point is not right here. Okay, for example, if you want to imagine what a cushion is, see, when you are wearing your footwear, okay, when you are having your flip-flops or sandal or shoes, then the sole of the shoe is acting as a cushion in order to provide comfort to your feet. Okay, that's what a cushion does. Okay, here we are talking about foundation, which is not acting as a cushion but a mean or a transfer medium to effectively dissipate the load of the superstructure to the soil below. That's why option C is wrong here. Option D gets ruled out because we have found the correct option, which is option B. Foundation reduces the load intensity of superstructure by distributing the total load to large area. Okay, with this, let's move to question number next. Okay, a foundation provides lateral stability to structure against what? Let's first see what lateral stability is. Okay, see, this is a structure and we have provided a firm foundation to it like this. Okay, see, now if the structure is tending to move sideways, okay, in any side on this plane, on any direction, if it is wanting to move, then it is called as sliding failure. Okay, then if at any point if the structure want to topple over or to roll over, then it is called as overturning failure. But what our foundation is doing, our foundation is anchoring the total structure onto the ground below. Okay, therefore it is resisting the action of sliding or the action of overturning. Therefore foundation provides lateral stability to structure against sliding also and overturning as well. Therefore option we should go with is both of the above, because both these things are tackled by providing lateral stability. Okay, let's go to question number next. Okay, how a foundation should be? A foundation should be such that it should not impair the stability of the structure. Yes, when we are constructing a foundation, when we are having a substructure which is supporting the superstructure, then it should not at all interfere with the stability of the structure. Okay, having a good foundation means not having any interference with the stability of the structure. Therefore option A is correct when we are talking about a foundation or a good foundation. Then it should not cause any differential settlement. Yes, let's focus the word differential. Settlement is going to be there. Settlement is definitely going to be there. But the thing that we have to take care of is the foundation should not cause any differential settlement or unequal settlement or uneven settlement. Okay. Therefore, option B is also talking sense regarding foundation. Then it should provide sufficient resistance to action of swelling and shrinkage of soil. Yes, in case the foundation is surrounded with soil such as black cotton soil, which on the addition of moisture content swells and upon the removal of moisture content it shrinks, okay, or it diminishes in size. Therefore volumetric changes take place when such kind of soil is there, and these volumetric changes cause a tremendous amount of stress onto the foundation or onto the structure itself. Therefore it should provide a sufficient resistance to action of swelling and shrinkage of soil is correct thing here. Therefore, since all the 3 points which are being talked about a foundation are correct, we will go with option D, which is all of the above. Okay, let's go to question number next. Okay, a foundation is called shallow when do we call a foundation as shallow? See, I asked the same question on the Instagram quiz palette. Then I provided 3 options over there. We call a foundation shallow. The first option was given as when depth is less than its width. Okay, another option was given as depth is more than width. Okay, when we are calling depth as depth is more than width, then definitely it is going to be deep foundation. Then the third option was given as depth is less than or equal to its width, but most of the people went with option which was depth is less than width. See, we have to be careful here while taking the option, because in multiple choice questions you don't have to take the right thing, you have to take the most correct option over there, because it may be possible that some facts regarding to that question are put in format of option, but we have to check the scene which is most relevant to the asked question. Okay, we have to take the most correct answer here. It may happen that all the 4 options are correct, but the most correct option is to be ticked when we are talking about multiple choice questions. That's why always pay attention to what else has been provided in the option when you think that you have found out the correct answer. Okay, so the first thing that they have provided is its load by area ratio is within 5.0. See, there is no such parameter that talks about when the load by area ratio, that is intensity, is within this or within that limit. Okay, therefore the first option is bullshit here. Let's cut it down. Second, its depth is less than or equal to its width. Yes, this thing, its depth is less than or equal to its width. Let's jot it down. Depth less than or equal to its width. Yes, this is the parameter that decides whether a foundation is shallow or deep. Depth being less than or equal to width, we will call the foundation a shallow one. Okay, and when the depth is more than width, we are going to call the foundation as deep. Okay, when width is more than or equal to depth, foundation is shallow. When width is less than the depth, we call the foundation as deep. Therefore option B is right here. Since option A got eliminated, option C has no role here, and since we have found out correct option, option D gets ruled out. Remember, depth less than equal to width or width greater than equal to depth, the foundation is shallow. Width less than depth or depth more than width, the foundation is deep. Okay, enough talk. Let's go to question number next. Step footing is categorized under, is it a kind of mat or rough foundation? No. Is it a kind of strap footing? No. Is it a kind of combined footing? No. Step footing is categorized under spread footing, which are spread footing are what? Spread footing support a single column or single wall, and they spread in area in order to the previously talked discussion where we had this intensity thing, load upon area. Spread footing just increase the area in contact, they increase the area for effective distribution or effective dissipation of load. Okay, load upon area. Spread footing do what? They utilize this very thing, increase in the area. Okay, step footing is nothing but a column will be there and a footing in format of steps will be given there. What is happening over here is the area is gradually increasing in format of steps. Okay, more area is made available so that the intensity for that specific column reduces. Okay, let's go to question number next. A strip footing is, okay, option is saying a strip beam joining two column footing. See, strip footing is a kind of spread footing. Do not get confused with the strap footing where strap beam is there. There is no thing such as strip beam. Okay, option A is incorrect. It is just there for increasing the confusion. Okay, then let's take a look at option C. Strip over which number of columns are supported. No, a strip footing doesn't support a number of columns, it supports a wall only. Therefore option B is saying a spread footing for a wall. Yes, a strip footing is nothing but a spread footing for a wall. Okay, strip footing for a wall looks something like this. For example, if this is a wall, then strip footing will be a surface over which this wall is constructed. Okay, this is your strip footing and this is your what? Single wall. Okay, let's go to question number next. Okay, a slope footing is the one which is a type of spread footing. Yes, slope footing, step footing are types of spread footing. Then it has a slope toward bottom. Yes, the name itself it is suggesting that slope footing will obviously have a slope. Okay, option B is right. Then a slope footing is the one which carries single heavily loaded column. Yes, whenever we are talking about spread footing, then isolated column is there which is loaded and the column's load is taken down to the soil below by having a spreaded area of the footing or the foundation. Okay, a slope footing looks something like this. For example, this is the column, then a slope is provided, then the footing is ultimately kept over the soil. Okay, this is what your slope footing, this is what your column. Okay, you can see the slope over here where gradual increase in area has been provided. Option C is also right. Therefore the most correct answer here is option T. Okay, so with this we have covered the introductory part of foundation and spread footing. In the next lecture we will take a glance on strap footing, combined footing and mat or raft foundation. Okay, till then, if you like the video, press the like button, share the video amongst your friend and subscribe to Simplified Learning for more such videos. If you are a Hindi viewer, do check out the second channel, Civil Engineering in Hindi, which is the second channel of ours. Okay, if you want quizzes, tests and PDFs of notes, then do follow the Telegram channel. And for purest of the pure civil engineering memes, for the funniest videos memes can be found on our Instagram page, which is Simplified Learning Civil. So do find all the links of given things in the description. Till then, take care and bye bye.